Welcome, ladies and gentlemen, to sqadia.com. My name is Osama, and today we are talking about interpretation of diagnostic tests and laboratory statistics. In this topic, we're going to talk about positive and negative predictive values and standard deviation, as well as we're also going to talk about the mean and how to calculate mean and standard deviation and positive and negative predictive values. So what are positive and negative predictive values? So these are actually values or measures that describe quantitatively the likelihood that a positive or a negative result in an individual is correctly predictive of the presence or absence of disease based on the type 1 and type 2 error which are likely to occur whenever we are going to talk about the positive finding and negative finding in any type of laboratory test or finding or an outcome measure. Positive and negative predictive values are actually dependent on the prevalence of disease, the one which we talked about in the previous lecture, unlike sensitivity and specificity, which are not dependent on the prevalence of the disease in a community. So, what is positive predictive value? Positive predictive value is a measure which is used to describe quantitatively the likelihood that a person with a positive test result actually has the disease. So it means it is actually identifying or helping us to identify that what would be the occurrence of the true positives from the overall positive calls. So if we want to calculate the positive predictive value, we can take the number of true positives and divide them by the number of true positives and the number of false positives, the sum of both. So in short, the positive predictive value is actually number of true positives divided by number of positive calls, which is actually a sum of both true positives and false positives. So if there is a greater number of false positives, then there would be a smaller positive predictive value for that test. And if there are a lesser number of false positives, then that test or an outcome measurement has a greater positive predictive value. Negative predictive value is pretty much the same thing as the positive predictive value, but it is actually focused on identifying the true negative. So the likelihood that a person with a negative test result is actually free from the disease. So the probability of finding that out or the prediction of finding that out is actually the negative predictive value. Once again, the number of true negatives divided by the number of negative calls, which is actually the sum of number of true negatives plus the number of false negatives, is the negative predictive value. So if there is an outcome measurement or a laboratory test which has a greater number of false negatives will result in a lower negative predictive value, whereas if any outcome measurement or laboratory test finding has a lesser number of false negatives, then that outcome measurement or laboratory test is found to have a greater negative predictive value, which is a good thing. Now let's talk about mean. What is mean? Mean in easier terms is an average, but there are different types of averages like mean, median, and mode. But mean specifically is usually used in different type of analysis when we are aware that the data is parametric and normally distributed, and it is one of the most commonly used averages. So mean is actually the sum of all the values divided by the number of the total items or the values. So if I say that there are 10 different values, we write them down and we add them and we divide them by 10, which is the total number of the values, and that would actually give us a mean value. For example, here we can see that there is the formula which is for the mean, in which we are adding all the values and then dividing them by the total number of those values. But for example, if you want to calculate an arithmetic mean of 5 values, which are 4 36, 45, 50, and 75. So you can see that there are 1, 2, 3, 4, and 5 different values. So we add them, we sum them up, and divide them by the total number of values, which is 5. So the sum is 210 divided by 5. So we get an answer which is 42. So the mean value for these different values is 42. And whenever we talk about the mean, there's always a term which is associated with mean, which is known as the standard deviation. So standard deviation is a measure that is used to quantify the amount of variation or dispersion of a set of data values. A low standard deviation indicates that the data points tend to be close to the mean set, while a high standard deviation indicates that the data points are spread out over a wider range of values. So for example, if I say that there are different values and the mean of them is 10, and if I look at the individual values, they are like 9, 8, 11, 12, and these values are actually close to the mean, so I would say that they have a low standard deviation. But if I say that there is a set which has the mean value of 10, and if I look at the component values of it, there is a value like 2, 12, 34, 7. So these values are far apart and very different from the mean. So we can say that this type of set would have a high or greater standard deviation. Now, how can we calculate the standard deviation? To calculate the standard deviation, we can use the formula. In this formula, where this sign is actually the sign of summation. So what we do is we take every term and the difference of each observation from the mean. So we take a difference of each observation from the mean and we add all of those differences, and then we take a square of them, and then that is divided by the total number of observations minus 1. So that is how we can calculate the standard deviation, and that is reported as, for example, if there is a mean of 10 and standard deviation of 2, so it would be reported as 10 plus minus 2. So in this lecture, we talked about the positive and negative predictive values and how to calculate them. We also talked about mean and standard deviation and how to calculate that as well. I hope you learned something new out of it, and thank you for watching sqadia.com. Keep on watching for other series of lectures as well. Thank you.